Okay, welcome back. So, we have Ellipse Geo. Yeah. AP, there are two on the ellipse such that. Oh lord. Okay, alright, here we go. Let's just put P like here. Da da da! Potato! Okay, cool. Oh lord. Yeah, alright. Cool. Alright, here's the foot of the altitude, guys. And then A, B, C. And then I'm gonna draw the two tangents. It's also, okay, it's 13, 14, 15. ADT1, ADT2. Okay, so, I mean, you phrase it in, like, okay, you're phrasing it in terms of area, but, like, you gave me a triangle with a fixed altitude. So you're asking actually about, like, this distance versus this distance. Right, it's like, if this distance is 3, I guess, what can the other distance be? And that is, the degrees of freedom do match up in the sense that we expect there's only, something. Okay, anyways. Oh no, Ellipse Geo. So I actually have no idea what I'm supposed to do. We're given, like, okay, it's 13, 14, 15, so 13, 5, 9, 15, etc. And then this is a... like, sure, but... oh god, okay. What am I supposed to do with the ellipse? Nani? Wait, okay, actually, here's the issue though. Like, aren't there a lot of ellipses? Like, if you only give me 4 sides, there should be a lot of ellipses inside the quadrilateral that are tangent. Yeah, there should be multiple ellipses that you can draw inside a quadrilateral. Like, you need to have a like pentagon before the inscribed ellipse is unique. So okay, now I take back what I said. Something's wrong about the degrees of freedom, because it feels like you have one extra degree of freedom for picking the, like, you can pick P, and then for each P there's a bunch of ellipses, and then you told me, like, I don't know, that the height is 3 or something. So either this is some dumb inequality, in which case I don't really want to work on it, honestly, or something's up. I think more likely something is up, and there's a reason why. There's some relation between the two lengths, or something like that, which I think is more what I'm hoping will happen. But yeah, because the problem is there's multiple ellipses. It's not an inequality. Yeah, I figured. I figured it was an inequality. You wouldn't bother sending it to me because it wouldn't be fun to watch me try it. Okay, so actually what I actually should do is take out GeoGebra, right? And then I don't know, man. Could the Canada problem be useful? Which Canada problem are you referring to? Oh, you're referring to the one that says that the angle bisector, right? Where I remember this. It says that if I draw this thing and this thing, it says this angle is equal to this angle. It might be. The reason I might believe that is because if I draw the foci of the there's some lemma, like, let me see if I can remember how it goes. Like, when you have tangents, like, actually, I should just extend these all the way. Like, there's a billion isogonalities in this picture. Like, so there's an isogonality at the top between here and here. And then there's an isogonality through P because these two are tangent. There's an isogonality through here. Through the red angle or something like that. And then now there's this blue isogonality as well. Yeah. So that certainly is interesting. So it's like I have this blue line, alright, and then there's these two red points on it that are the foci. And yeah, let me just draw the isogonal pairs. Okay, like I think the important one is like P. There's thing through P. And now, like, you know, one pair here, one pair here, and then another pair here. Actually, the green one's fake. The green one is isogonality through, like, the red ones. I mean, it might end up being just isogonal, like, period as well. But let me start with just these. Can I say something in this picture? I'm gonna give these a different... Does that happen? It would give a good reason why it's the altitude in particular, though. Like, because I was kind of... I wonder if the red thing passes through. Hey, does the red line pass through, like, the feet here? In the sense that... Okay, if I want the red thing to pass through the blue, I need the... This through D to be... yeah, I don't know. Like, I guess another way of thinking about it is I could actually just not pay much attention to AB. Actually, I think ABC is a little red herring-ish. Like, I think it's like I should think of AP, let's get these names, alright. APEF, or AFPE. AFPE is a quadrilateral with the property that the pole... The pole of... The pole of AFPE, like, or EF intersect AP with respect to any circumconic of AFPE is the point D, or something like this. Oh no. I'm not liking the reactions I'm seeing in the chat. I really want the 4 points FE and the 2 T1, T2 to be collinear. Like, it would feel... If it would feel like things are checking out, because if that's true, then the Brocard that I was talking about earlier, like FE and red FE being collinear is the same as... Shit, what was the same as? 3 poles being concurrent. Those poles should be... Or, sorry, no, it's 3... Yeah, I think it comes down to something like, okay, yeah, this is a projective statement. I think the projective state claim that I'm trying to make is if I have a red ellipse like this, and then I have boom, 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 like that. And then I take, you know, this point here. I want this point to be on the pole. I want this point to be the pole of that line. Is that true? It feels true. It feels like it should be true. With respect to the inconic. If it is true, and I think it is, then I can try to prove it by taking the red potato to a circle while mapping this point inside to the center of the circle, in which case it better be true. Shit, it's false. No. Actually, no. Yeah, it's true. Alright, brilliant. Isn't this just the deal of Brocard's theorem? Probably. Okay, so I was totally right. This whole thing is clear. And now what's happening is I have a point D and I have like 2 isogonals. And they can be really any isogonals. It's like, you know, I have EF and then... Yeah, because I have 1 degree of freedom, this is where the degree of freedom should come in. Like, I should be able to take any point... Wait, sorry, what thing was isogonal to what? So, something is something. What am I trying to say? All right. So the other thing, I need something else, like because I also have this thing where I have these points, and I'm betting that I have some harmonic crap, right? Like I want like blue red to maybe not harmonic. I need some condition on like these four. Because from this picture, if I have, oh, I don't know, man. So I need something that lets me say, say something. What am I trying to do with this? Do I want like some sort of like dual? This. Like I feel like this has a Desark-ish feeling to it. There's a there's an involution that damn, I don't. I'm trying to remember the statement of Desark involution that I like never use, so it's not going very well. Yeah, I really I want to not bring the foci in, I think. So I need something about the ellipse that tells me like I need to be able to say for a point on EF, here's T1, how do I get T2? And I know that's an angle bisector, and I know that other things. Yeah, I'm trying to throw away the foci, but I need something that tells me like if I have a quadrilateral. Actually, if I have a quadrilateral and then with the property that it's I don't know what the word is. Can AFP can be AFP can't be any quadrilateral, right? Like there's some condition that says that you need actually, for that matter, in this stupid projective thing that I've written, I didn't even use the right angle yet, right? Like I'm literally just saying like, look, FE by the what I'm being told is like the inverse of Brocard or whatever. Not inverse. The dual from the dual of Brocard, we know that FE T1 T2 are collinear. I think that's what we have so far. We haven't actually used the right angle. And what I want to do is I want to I don't know what I want to do with that. What do we do? We spent a god awful time on a linguistics question where I learned that apparently something about cross cousins and parallel cousins. I don't want to know. And then we did a Philippines question that I thought was cute, and now we're doing this thing. Can you project involutions? What does that mean? I mean, also probably yes, but need to be a little more specific on what you're trying to do. I see. You're telling me I should be using the dual of Desargues involution theorem. Is that what you're telling me? You're telling me that by dual Desargues from the point D onto APEF with its inscribed conic, DPDA, the two tangents, and DFDA. Okay, yeah, that's what it is what I thought then. Like not only are those an involution, but also I feel like this is too strong. I feel like I have one more degree of freedom than I was betting on. Wait, but from dual Desargues. Oh, the board's acting up again. From D to AFPE DDIT. Yeah, okay, that's where you use the right angle, because the Canada problem tells you that you have these blue angles here, and then DA. So, in fact, the red things are also bisection, like this angle is equal to this angle, or whatever. So, I think at that point we can just throw away the ellipse. If I haven't messed up, by... Okay, because D is specifically AP intersect BC, the two red lines lie on line EF, but also because of the Canada problem and DDIT, these two angles line up. So now we can throw away the ellipse, which is great. Best news I've heard all day. Instead, what's happening is you just have a triangle ABC. You have a random point on the altitude. And then what's happening is you're considering the... So it looks like the orthocenter, but it's not supposed to be. What's happening is you're considering like 2 points which are reflections around here. And it's like, if one of them is 3, what is the other one? Is basically what the problem is saying. I'm sorry, I didn't mean to draw the orthocenter. Alright, guys. I have an idea. What if we just set this to 0, 0 and 0, 12 and minus 5, 0 and 9, 0? How do you all feel about that? Banned. I don't know if I don't really want to do it. I don't know. Okay, but the point is there should be some relation between the green numbers. I don't know what it is, so I can't tell quite by looking, but that's a little surprising to me, actually. It's just, in general, if I have... What? Okay, I have an angle bisector theorem, right, where... Okay, so if I look at the green altitudes, I don't really care about these altitudes. What I really care is like, okay, you know, by similar triangles, the ratio from here to here is equal to... Okay, the green triangles are similar. Maybe that's all I should say. And so it's D... Alright, well, we'll give these points names. Actually, they're already named. This is T1 and T2. Like, the ratio of the heights is equal to dt1 over dt2. And... Are you telling me this is like a fixed number? is that really fixed? There's no way it's fixed. Okay, I agree there's no way it's fixed. On the other hand, is 3 like a special number then? Like I don't... Or maybe what you want me to do is, okay, maybe what we can do is we can, you know, look at this point. Actually, that's probably better. Here, all right, okay, cool. I think I see where this is going. We're going to complete the harmonic bundle, D, E, F, X. Oh, frick. See, I usually would call this point T, but there's already T1 and T2 in the problem. So, what's happening is Y, F, E are fixed things. Wait, no, they're not quite fixed. What? Hang on. But okay, there's an involution is what I was trying to say. So I have this harmonic bundle, and then T1 and T2 are also such that, yeah, T1 and T2 is also harmonic. So the thing that I'm trying to get, which is Y, okay, it's YT1 over YT2. I don't think that actually helps me very much. What if I just project, like, straight down? Like, okay, like, I don't know, like, actually, we know, okay, oh, I understand, okay, I think I see what's going on. We're just gonna project it straight down. I was trying to do similar triangles. Actually, the similar triangles is too fancy. What's happening is, like, you know, let X and Y be what I said they are. Then, YX T1, T2 is harmonic. When projected down here, this is 3... or either that or on the other side, and then Y is fixed and T is fixed. I think this is the intended. Right, I was getting too cute. But because it's an altitude, you can shoot it straight down. And then, yeah, so one of the values, so if I do this, I don't remember where Y is, but the point is, like, when you look at the projections on to this fixed line, YD, you know where they are. 13, 4 to 7 to... So this is what? 7, cheese, this is, yeah. This is like 49 over 4 or something. So you have one case where T1 is here, and the other one is, you know, this is 3. And then whatever makes this a harmonic bundle. Or the other way, where T1 and T2 are flipped, and then it's on the other side. So either way, you take the two harmonic bundles. Okay. Cool. Do you all want me to actually do the arithmetic? Because if you do the arithmetic, I'm making you all help me do it. Also, I lied. It's not 49 quarters, it's 49 halves. There's a faster way of computing. What do you mean? Is this not optimized? Like, I feel like you can't... Like, it is what it is, right? Like... Alright, fine. If you say there's something going on, I'll... No, I'm just gonna compute it. Like, this is so easy that there's no way it's gonna be hard. Okay, we're gonna put it on the number line again. So now here's 0. So now our radius is 49 over 4. Here's D. Here's minus 49 over 4. So one of the pairs is if I have 3 here, then... Oh my god. Help. Shiba. You really... Do I really need to... Wait, why did I end up with 2 squares? Oh, also, the 3's going the wrong way. One of the points is 37 quarters. Which gets inverted. Oh, God. Yeah, no, you're right. It's 37 quarters, and then 2401 over 4 times 37 is one of them. The other one is if I start from 61 quarters and invert downwards. It's like 2401 over 4 times 61. And so the answer is supposed to be like this thing plus this thing all times the altitude 6, which I didn't include. But like the sum of the 2 possible values is given by 2401 quarters. And then 1 over 37 minus 1 over 61. So this is the sum of the heights. And then to get the final answer for the area of ADT2, it's equal to this. So now I have to actually do this calculation. And I mean, I don't, like, are you gonna get a way that's simpler than this? I don't really find that believable. Because I mean, this is your answer, like, it is the answer, right? Whatever the hell this simplifies to. This is not what we got. Okay, well, what did I do wrong? Like, I'm right that, like, YT1, XT2 is a harmonic bundle, right? And then the point is that now you project onto the bottom. And then, unless I didn't did I miscompute dy? That's possible. I could have miscomputed dy. 49 quarters. Sorry, 49 halves. Oh shit, I forgot the minus. Oh. Sorry, it's not 49, it's 45. Because you have to subtract the 2. So it's like 7 and then 2 away, so 49. Yeah, 49 halves and then, oh, frick, okay. 45. So I now have to change every, oh lord. 45. Well, that's actually good news because that makes the numbers less disgusting. Because you don't have this factor of 7. So subtract off the 3s, add on the 3. Alright, so now it's 33 here, and then 57 for the top one. And then... I mean, I just fixed the numbers, right? 33, so here's the 33, here's 2025, here's 2025, here's 57. And we didn't actually use the coordinates. I was just putting them there saying that this should work in theory, and then we didn't actually use them. Okay, so I mean, yeah, I mean, You replace the squares with the correct thing, so now it's 45 squared, and just 33 minus 57, which is whatever the heck it is. Oh man, arithmetic is really hard. 4, 33, 57 on the bottom, 25 times 6 times 24 on the top, and then this will simplify to something. I don't know exactly what. 6. Yeah, the thing is the 19 doesn't divide, right? So the most I can simplify is I can pull out a factor of 12 and I can pull out another factor of 3. So this is like 8100 over 11 times 19, I think. Yeah. So, I mean, is there a way that's faster than this? Because I already feel arithmetic-wise, like, this is pretty close to... There's black magic that gives 1 over distance 1 equals... Are these mock AIME suggestions? No, I think this, Although, actually, this is the kind of problem that I would think people would vote for on the Otis mock AIME, because it's like... I don't know. Well, anyways, okay. This is not bad, actually. It is the kind of problem I would put on an Otis unit. I'll put it that way. It's like worth seeing. T1 and T2 to AD. Alright. I don't really want to write this up. Maybe I'll write it up later. I'm kind of tired. Will you do mock AIME proposals on stream? I might do... Well, okay, last year I did a mock AIME stream. So for the 15 problems that we actually put on the Otis mock AIME, I did a stream for all 15. Might do that this year again. Right now, the thing in my life is that I have to defend my thesis in 54 days. And it means I need to actually finish this thing up. Yeah, but yeah, the Otis mock AIME will actually be after that. Yeah, if someone puts the suggestion on the stream, I'm not putting it on the actual mock AIME. I think that much should be obvious. You know, there are some people who are actually using it as a practice AIME, and they would probably not like to be spoiled on the problems. Although it is the Otis mock AIME will be harder than real AIME because we always end up that way. The problems that people like, I don't think it's like way harder. I just think it's like the problems that we like tend to be on like a little bit harder than the average problem on the real AIME. Like we could put some easy problems to make the difficulty balance out, but then we don't get to show the cool problems that we want to show, so it's like fine. We'll make it a little harder than the actual test. Anyways, okay. For those of you on YouTube, thank you for tuning in. That's all for this. I hope you learned a bit of projective geometry. I will probably eventually write up a solution and post it as well, so you can see that. But yeah, that is all.